Hey guys, Stephen Fleet here, 25 January 2026. Hey, I wanted to talk about the twin prime conjecture. Something interesting that comes out of this kind of hybrid Dirichlet series I discovered some time ago. Um, if you get a chance, go back to look at some of the previous videos where I explained this more in depth. But in essence, this combination of formula 3x plus z, where z is this, gives you all of your prime numbers from 5 and above. It doesn't skip any, but also includes a lot of different composites in it, just by the nature of the formula itself. Now, what's interesting is that you can predict the location of all the composites, and so anything that's not predicted by this matrix is a prime number. Now, how this relates to the twin prime conjecture is that when you look at the definition of the twin prime conjecture, is that there's infinitely many twin primes. So, for example, 17 and 19 are twin primes. Basically, they just differ by 2. Now, you can prove that through this matrix. This is the x values, the locations, so the x values here, location of all your composites. And so your twin primes will live in between. So for your composites of 5, it goes 3, 7, 3, 7. And, for the 7s, it goes kind of similar. It goes 9, then 5, then 9, then 5. And the delta between the first and third or second and fourth would be 10, then 14, and so on. 10, 14, 22, 26. So basically, your different factors of composites, 5 times 5, or 5 times 7, or 7 times 7, 5 times 11, 5 times 13, they are separated by this amount, plus 4, then plus 8, then plus 4, then plus 8. It grows incrementally. Now, reason why that's important is that these different factors are staggered. And since they grow larger with each different factor, as you would expect, what that means is that your twin primes, they become less frequent, but they don't go to 0. So they just essentially space themselves out, but they never diminish to where there's no possibility of twin primes left. And so when you graph this, you can see that statistically it becomes less likely, but it's not impossible. So you kind of have to solve it like Bell's theorem. You have to solve it statistically, and you can prove the twin prime conjecture with this, because you know where every composite is, and you know where there's not a composite, there has to be a prime. And where there has to be a prime, you can figure out through this equation where they are, essentially through an exclusion process. Thanks.